How can someone tell if their immune system is healthy?
A lot of doctors, they only think about the immune system with one marker, C-reactive protein. That's all they do, and they say, oh, you're inflamed. Now, what happens with aging is that sort of your total leukocyte counts go down and your total lymphocyte counts go down. Lymphocytes being sort of these sentinels, policemen, or elite forces of the immune system. Inclusion body myositis happens classically in a 65-year-old. The two key hallmarks in this disease: shot mitochondria, damaged mitochondria, and damaged immune cells. So I do believe that if we can tackle immune aging earlier, we can keep all the other organs healthier much longer. For many years, things like Alzheimer's were basically protein deposits in the brain. Now it turns out that all the immune cells, the microglial cells and all the immune cells that they can actually cross, they are in the super dysregulated state. They are in a super inflamed state. And now that whole field is turning out that actually Alzheimer's is an inflammatory disease.
Placebo affects 30%. So for example, if I say, take this pill, you're going to get better, maybe there's a 30% chance that that works.
That will work for muscle. Immune system, you cannot deceive.
Wow. Dr. Anurag Singh, it's always a pleasure to see you.
Lovely to be back.
Alzheimer's disease of skeletal muscle.
It doesn't get a lot of, let's say, visibility, but one of the things that happens with aging in the skeletal muscle is sort of this muscle immune dysfunction, right? So people probably need to be aware that a lot of immune cells tend to hang around in the skeletal muscle as they do peripherally in most organs. They're kind of the sentinels watching out where the danger is. These immune cells, they kind of become dysregulated. With aging, muscle has become dysregulated. So you get this sequelae of like a double whammy where your muscle is, mass is going down, your strength is going down, and you have this immune dysregulation. What that leads to is something called inclusion body myositis. So it's almost like you're seeing these protein deposits happen with aging in the skeletal muscle, just like in the brain.
It's crazy. You and I were chatting before, because sarcopenia, decreased muscle mass and function that we think about in an aging population, there's probably a phenotypic expression of youth, right? Especially now with the use of GLP-1s, potentially we're accelerating aging. Obviously, there might be some positives to that. But then this idea that, number one, that there's a lot of immune cells in skeletal muscle. Frankly, I hadn't thought much about it. Secondarily, this idea that skeletal muscle can become dysfunctional beyond decreased muscle mass, strength, mitochondria. But what you were talking about is sIBM, which is this sporadic inclusion body myositis. People think that that's probably rare, but there's a lot of likely myopathies or diseases or inflammatory effects of skeletal muscle.
Absolutely. So as you said, over the human lifespan, there's a lot of myopathy. Some happen in kids, some happen in middle years of life. This is sporadic inclusion body myositis, happens classically in a 65-year-old. They'll come to you in the clinic. They're mostly misdiagnosed for a long time because people tend to think, oh, it's sarcopenia or pre-sarcopenia. It's just, your mass is melting away, your strength is going down, until the acceleration is so fast in probably a year from the first time somebody with a 65-year-old says, oh, I can't get up properly from my chair, I can't walk. They do a biopsy and they found the two key hallmarks in this disease: shot mitochondria, damaged mitochondria, and damaged immune cells.
Well, hopefully we're going to talk a lot about how do we keep those healthy. And perhaps, again, I don't know if they know what the root cause of this sporadic inclusion body myositis is, right? They don't. They think it's an autoimmune dysregulation.
It is. It really is an autoimmune condition of the muscle. And it's also an age-related condition of the muscle. A lot of research has happened in the recent past. Still a rare disorder, but I believe it's misdiagnosed and underdiagnosed.
I hope you're wrong. I usually don't hope you're wrong, but I hope you're wrong on this. One of the reasons I love having you on is you are actively involved in research and you're also a physician. And you and I are going to cover the immune system. Sure. What's new? What's some of the new emerging data, the skeletal muscle immune relationship. But, as we are thinking, how can someone tell if their immune system is healthy?
I'm a trained immunologist, and as you mentioned, I come from the medical world. A lot of doctors, they only think about the immune system with one marker, C-reactive protein. That's all they do, and they say, oh, you're inflamed. And that's pretty much their knowledge, except that they may have been taught a lesson or a class in med school where there are two immune cells, T cells and B cells. What happens with aging is, and pretty much you can do a blood panel, and if there are physicians and doctors listening to this conversation, you can pretty much do a total leukocyte count and know what your white blood cell counts are. You can also do what is called as a differential leukocyte count, which gives you an idea of how many neutrophils are there, monocytes. These are the different classes of immune cell. But the key two things that happen is that sort of your total leukocyte counts go down and your total lymphocyte counts go down. Lymphocytes being sort of these sentinels, policemen, or elite forces of the immune system.
Do we have an idea of where we want those numbers for a, quote, optimal immune cell function?
So there are about a few trillion immune cells in the body. Their numbers decline. So there's an organ called the thymus that pretty much is fully functional in our teenage years and then starts in what we call thymic involution. So by the time we hit 20, it's seeded all kind of different knowledge to the immune system and just withers away. And then that's what you're left with all your life.
Why though? That seems like a biology kind of biological design flaw.
It's a great question, and I think it was evolutionary. It was set, we were living, 40 years and 100 years back. And I think what happens is it just gives you enough ammo thinking you're going to live so long. And by the time you get to 50, 60, all that ammo is just gone. And again, the biggest problem is these immune cells get fatigued. They don't wither away, just get kind of like senescent, And so there are two things happening in this field. One, can we somehow regrow the thymus? It's possible. There are a lot of strategies being used to see. The second more strategy, which I believe, is can you keep these reservoir of immune cells healthier longer? Can they be kind of functionally more energetic to kind of fight?
Can I ask you this? If we were to frame this up, when you're born, you're not born with all the immune cells that you'll have. Sure. We get some immunity from our mother. We develop immunity over time, right? Yeah. That's all correct?
That's absolutely correct.
And then once the thymus atrophies, which we still have it, but it's very atropic, do we have the amount of immune cells that we will always have? Are they able to replicate?
Yeah.
Does it depend on the location, whether it's in, I don't know, the liver versus the muscle? How do we think about that?
So within this pool of, let's say, the billions of cells you're left after the thymus involutes, you're left with a few stem cell-like T cells. These are called naive CD8 T-cells. They're called naive because they're new. They're very youthful and they respond very quickly the moment you see a new viral or bacterial infection. What happens is these naive CD8 guys, they disappear starting around 40, 50 years of age. They could disappear almost to 1/4, so just 25% of what we had when we were 20.
25% CD8 cells.
They're left. That's all that's left, yeah.
One of the things as I was preparing for this episode, I was thinking, okay, we have all of these cells, these immune cells, various types. We can measure them, whether it's a neutrophil, lymphocyte to monocyte ratio. I don't know if you find that those are valuable.
Those are.
Okay. Can we touch on that? And there's a reason, is I almost feel like, and obviously you might disagree, are these clinical, would you consider these clinical endpoints?
I would actually, because I work in the aging health span field. And for me, we talk a lot about muscle as being the key longevity organ. And I think the second one we can talk about is the brain. But I think this immune as a system, as an organ, has been very understudied in the aging field. And I think just because these are the policemen patrolling all these organs, their axis, the connect, and we talked about at the start how, if they go bad and then the mitochondria go bad and then the muscle goes bad. So I do believe that if we can tackle immune aging earlier, we can keep all the other organs healthier much longer.
I want to talk about how we tackle immune aging and then what's the relationship between muscle and immunity.
Sure.
But when I was thinking about this, I was thinking to myself, okay, so what's the normal amount of sickness
Yeah.
that someone would have? And I'm going to share with you what I found.
Yeah.
And this says for a healthy adult, it's considered normal to experience 2 to 4 episodes of an upper respiratory infection, such as the common cold, per year.
Yeah.
And then it was like 1 episode of acute gastrointestinal illness per year. Gross, that's rough. And then children, I was thinking, okay, well, if that's for us, if what is normal is 2 to 4 episodes of some kind of infection, for children, they average 6 to 8 colds
Yeah.
per year versus an adult would be 2 to 4. That's unusual.
Yeah. So, we started getting into this. As you're born with no immune system, and then it develops and kind of tries to learn very fast because it's got this 10, 15-year window to quickly learn. And actually, there are studies where they've looked at big families versus single kid families. If one child gets sick, the others will catch it, or if the kid is going in daycare versus not. So the more it learns early on, and so that's the kind of where you're saying is that the kids get sicker earlier on. It's just kind of getting the immune system, it's what we call immune imprinting. So it's kind of getting these memory cells, these immune T-cells, to remember if the infection comes back when you're adult to, I know this guy, I'm going to now divide faster than I was when I was younger, and I'm going to try to kill it. The problem is they just are so fatigued and exhausted by the time we get 40, 50 years old. They just can't mount a proper immune response.
You've heard me say it before, muscle is the organ of longevity. Now I'm putting the playbook in your hands. My new book, The Forever Strong Playbook, is your roadmap to building real strength, not just in your body, but in your health, your energy, your life. This isn't theory. Inside, you'll find the exact workouts, protein-forward recipes, recovery strategies, and mindset tools I use with my patients and live by myself. This book is for anyone and everybody who wants to age powerfully, stay vibrant for their family, and show up strong every single day. When you pre-order, you're not just getting a book, you're joining a movement. The link's in the show notes, and I cannot wait for you to dive in. What is the relationship between immune health and muscle?
I think it's a very key axis, and an axis that I've started studying a lot recently because I was an immunologist who accidentally came studying mitochondria into muscle, and now I've gone back. The relationship is there are a lot of immune cells in the skeletal muscle. So if you were to look at somebody who's frail, and I've done this, I've looked at 75-year-old people's skeletal muscle. I take a little piece of muscle through a procedure called biopsy.
Where do you biopsy them?
I biopsy them in the vastus lateralis, which is one of the quad lower leg muscles. And so what we see actually when you compare fit 75-year-olds who are strength training, running for 10Ks versus 75-year-olds who are frail, sedentary, have been sedentary probably for the last 30, 40 years of their adult life. The top 20 pathways that light up are all linked to in the muscle, are only linked to 2 main biological hallmarks of aging: poor mitochondria and immune cells dysregulation. And it's fascinating.
Wow.
So I do believe these two. Now, the big question in the field is it the mitochondrial decline happening first, or is it the immune decline happening first? We don't know yet, but that's the axis. It seems like almost these are 2 friends that always need to watch out for each other. But if one goes bad, the other gets compromised in the skeletal muscle.
But there's a way to actively improve mitochondrial health versus, aside from eating off the floor, how do we improve immune health?
So immune health can be improved certain ways. Immune health in general, when we say what is immune health, I'm talking about 3 or 4 things. One thing we talked about is your youthful immune cells just disappear. So how can you bring them back or keep whatever pool of healthy cells you have longer? Second is your bodies get inflamed. So the kind of stress to the immune system, this is a process we call inflammaging. And the third thing that happens is immune cells get exhausted. And so all the top selling drugs that are tackling, for example, lung cancer or prostate cancer or breast cancer, are trying to revive these immune cells from their exhausted state. So that's kind of immune aging. And what we try to do is bring these immune cells back through multiple strategies.
The idea of immune aging. So basically, our bodies get older and our immune system also gets older. Do you think that, again, I recognize that you're a trained immunologist. Do you think that that's across the board? That all of these systems are, I don't know, accelerated in aging?
Well, of course they are, but I do believe there are three key pillars of longevity in terms of organ. Muscle, skeletal muscle, you gotta move, right? You gotta do your exercise and eat well for your skeletal muscle. The brain, your neurons and how they kind of fire and talk to each other kind of declines with aging. So the brain is the second key. I think connecting all these two, and even other organs you talk about, the liver, immune cells are there, is the immune organ. I think these three organs, if we can find interventions that can halt or slow aging, we will have massive impacts on health span.
You know, you were part of a group that just published a paper. This was actually October 2025. So I'll read it. It's the effect of the mitophagy inducer urolithin A on age-related immune decline, a randomized placebo-controlled trial. What is the difference between mitophagy and autophagy?
Autophagy is at a cellular level, okay? Autophagy means self-renewal. So when our cells get stressed and they feel their organelles are getting sort of damaged, it's the body's way of clearing the waste and the damaged organelles out, right? So fasting, for example, is a well-known autophagy inducer. There are nutrients that can induce autophagy. And then you have all these organelles like the mitochondria, the lysosomes. There's very targeted autophagy in these, and that's what we call, for example, for the mitochondria, targeted autophagy inside the mitochondria is called mitophagy.
So it's really specific to
the mitochondria, and there are thousands of them inside a cell. If like a muscle has about 15,000 mitochondria, so it's targeted autophagy of these mitochondria, the damaged ones.
Is there a ratio between mitochondria and these immune cells, or is it based on mass? If we think about what is good for mitochondria is probably good for immunity, but then also I just think about in terms of the amount. Do you think that it's related to the density of mitochondria in muscle?
So we certainly see lower mitochondria in the skeletal muscle with aging. We certainly see in damaged muscle, or frail muscle or sedentary muscle, lower amount of mitochondria. If we take the immune cells in the body or in the skeletal muscle, we also see the same decline in terms of mitochondrial abundance. And we can do that by looking at mitochondrial DNA, which is, mitochondria have their own DNA. Or we can use a marker called PGC1 alpha, which is a marker of how well they can, start their own process of renewal. And the third thing we can look is how is their function. And so, yes, the mass of mitochondria goes down. So compared to a muscle cell, which has about 15,000 of these, an immune cell will have a few hundred or 1,000. But just because there's so many of these immune cells inside the skeletal muscle or in other organs, you're probably talking about, in terms of the number of mitochondria, the same ratio.
Interesting. Okay. That would make sense. Talk to me a little bit about this study, and I'll just highlight some of the endpoints. So you chose a handful of endpoints. And again, a randomized placebo-controlled trial is the gold standard. This was in Nature Aging, just top tier, no big deal. It's kind of like the Super Bowl. Yeah. But you looked at the phenotypic changes in these peripheral T-cells, and these were CD3 T-cells, which I didn't do great in immunology. It's pretty complicated with the CD8 and CD3. So you looked at the changes in these T-cells. You also looked at something called immune metabolic remodeling. So I want to pause there. Can you tell me about how you chose these endpoints?
So we chose these endpoints because, that we have focused so much on muscle for the last 10 years. Two groups independently came to us, one from the Buck Institute of Aging, the group of Professor Eric Verdun, and a group of cancer researchers came to us about 4 or 5 years back. And they said, hey, we think what's happening in, whether it's aging in terms of what the Buck was studying and what these cancer researchers were studying, they started finding problems with mitophagy in how these immune cells would see the cancer but couldn't respond to it because their mitochondria were so damaged, right? So it's almost like cancer or aging, both are destroying the mitochondria from the same, looking at the same side of the coin. So they started doing these preclinical studies, and they published it several years ago in a very prestigious journal called Immunity. They showed that if you charged up the mitochondria in these CD3 T-cells, you would get better immune response, and you would have, in these models of cancer, almost sort of lower mortality.
Wow.
And so they came to me and said, well, we want to do a cancer trial. And I said, well, hold on, I'm not a cancer researcher, I'm an aging researcher. If they are the same sides of the coin, aging and cancer, maybe we study a cohort of 50 plus year old and we see what's happening at that level. So we did this randomized placebo-controlled trial to look at their two biggest findings these two groups were seeing. One is that these naive CD8 T-cells, these stem cell-like youthful immune cells, could we proliferate them? And would the proliferation, as in proliferation meaning, could we increase their number in the body? And second, would having better mitochondria lead them to dividing and having more? And what we find is actually both are true in this cohort of aged 50-year-old plus individuals.
I mean, that's a really big deal and a really big finding for aging, but also potential. And I know that we can't really say potential use in cancer, but I mean, those are pretty profound impacts, would you say? And I understand it's also a small group.
Yes. So the way clinical trials are done and really gold standard trials are done is you have investigators who don't know. You have to have two groups, right? So if you're right, this was a cohort of about 50 subjects. They were, the investigators were blinded. 25 got placebo, 25 got Urolithin A, which is a postbiotic nutrient known to be a mitophagy inducer. And then they took it for a month, and then we evaluated the changes happening at a single cell level, looking at millions of these immune cells. And that's how we found these impacts in 1 month, which is pretty remarkable.
It is. And that's what the phenotypical
You got it.
changes would be in this peripheral group. Thank you to Body Health for sponsoring this episode. A lot of people tell me they feel like their energy just doesn't go as far as it used to, that their workouts feel harder, recovery takes longer, and even mentally they hit a wall sooner in the day. I know I feel it quite frequently. But one supplement that I have been using and frequently appears in research, especially when it comes to cognition, is creatine. Creatine's main job is pretty simple. It helps your body recycle ATP, which is the quick energy your muscles and your brain rely on when demand goes up. That's why people often notice a little more endurance in their training or less overall fatigue. For muscle support, most studies use about 3 to 5 grams, especially when paired with resistance training. It can help with strength, muscle mass, and even muscle protein synthesis. There's also, which I think is fascinating, interesting research on the cognitive side. The brain uses a surprising amount of energy, and creatine may help support these things like alertness or memory, particularly during periods of stress or limited sleep. Speaking from a friend perspective, of course. Those studies often explore higher amounts, sometimes around 10 to 12 grams per day. And some early data suggests that it might even support blood sugar indirectly. So if you're someone who wants a bit more physical or mental stamina, or perhaps you're just trying to maintain muscle as you age, creatine is one of the simpler tools worth considering. It has been around for a long time. My go-to is Body Health's creatine. And using the link in the description, if you'd like to try it, you can use the code LION20 for 20% off your first order. So there was a couple other things that I was curious as to also how and if you looked at. So I do believe you looked at mitochondrial mass.
Yes, so we looked at mitochondrial mass, and I didn't answer your second question, what is mitochondrial remodeling, which is basically all the mitochondria or in the cells, especially in immune cells or muscle cells, they like to use glucose, okay? And that's the problem, right? If you can switch to using fats instead of the glucose, that's the remodeling. And that's how we have now worked with another group which has a dye that can go in these immune cells, look at how the mitochondria are, what is the fuel source of these mitochondria. And they we saw about a 20% increase first in mitochondrial abundance. So just being on the active supplementation through urolithin A, we see about 20% more mitochondria in these immune cells. And then they're about 40% better at sort of, instead of using glucose, fatty acids.
So we should pause and talk about that. So basically, for example, skeletal muscle at rest should be burning primarily fatty acids.
You got it, yeah.
However, when we are over consuming carbohydrates and deranging our metabolism, we force muscle to utilize glucose.
Yeah.
And that's not ideal. It's really creating this somewhat unnatural state. Yeah. Typically, those individuals, this is outside of physical activity. I really did think that that was fascinating. I looked up that urolithin A resulted in reduced glucose dependence and increased fatty acid use. What about amino acids?
So for that, you would have to do a different
tracer study.
Brutal. And that would be a bit brutal. But what we did see was the effect was very specific to these T cells of growing their numbers. There was another group of cells that we call natural killer cells. So think of these as like Batman and Robins. If these CD8 T-cells are Batman, natural killer cells are also what you need to keep going to fight. So we saw these two populations increase. And what we see is actually, this is the field of immune metabolism. We see almost all the immune cells use more fatty acid than glucose, just not the T cell. It's like rewiring the entire immune system.
Do you think, at rest, if fatty acid is the primary source for mitochondria, do you think that would be and should be the primary source for immune cells as well?
I think so, and I think that's the preferred source, and that's why a lot of, for example, even the therapies or interventions that work, for example, ketones, right? So a lot of medium chain triglycerides are trying to shift this metabolism, which every trial we've done with this molecule urolithin A shows us, whether it's in the muscle or immune cells, that you get the switch.
The interesting part is that urolithin A is a postbiotic.
True.
Where how many percentage of people can make it? Is it 30% or so?
It is 1/3, yeah. So it's about 30 to 40% healthy adults, meaning those who are eating the right foods, etc. And it's very different in geography. So for example, countries where Mediterranean diet is very common, like France, Italy, for example, we see about 40%. I've done studies in the US and Canadian population. It's like 10 to 15%. It's almost half that.
Which is concerning because basically, typically what you're talking about with this compound urolithin A, which I've talked a lot about, is that there's this gut mitochondria and muscle connection.
You nailed it. I call it my trifecta, gut muscle immune axis. Now also, as we get more and we can talk about it, we are also getting interested in studying the third key organ, which is the brain. I believe there's also a gut-brain axis where the gut is like a mini brain, and it's kind of, polypharmacy. If you lose the capacity of the healthy microbiome and these postbiotics, you're affecting your muscle, you're affecting your brain, and you're affecting your immune system because it's everywhere.
Which is not really spoken about. We talk a lot about antibiotics and then the effect on the gut, right?
Yeah.
But we don't think about the antibiotic effect on skeletal muscle, which might be indirect because of the effect on
the gut.
Yeah, and with the postbiotic, the ability to create urolithin A. And when I was also thinking about urolithin A and other compounds that would induce mitophagy, I was thinking about these various pathways. Because what if someone, let's say they have a really disrupted gut microbiome, they eat pomegranate and they don't make urolithin A, and they're not taking urolithin A, then this pathway, it's PGC1 alpha, is that the pathway that urolithin A works on?
Well, it's on the biogenesis. That's the biogenesis pathway. But the pathway it will first trigger is the mitophagy pathway, which is it will activate these sort of, it will target the eat me mitochondria. So the mitochondria, when they get stressed and damaged, they put out this eat me signal, and they need a few proteins called like Parkin. And so actually when we age and Parkin gets mutated, you get Parkinson disease. So that's how.
Wait, you have to pause on that. You have to pause. That's too important information. Yeah. Talk to me about that.
So in the mitochondrial life cycle, okay, you have the biogenesis. So which is meaning you're always growing your healthy mitochondria. the biomarker to know that, or the signal to know that, is PGC1 alpha. So if you have upregulated PGC1 alpha, it's probably 100% true you're having biogenesis happening in whatever cell type you're looking at. So in a lot of exercise will induce PGC1 alpha.
How much exercise? Do we know? The dose, 150 minutes?
In older adults, because that's the one I've studied a lot, 3 times 30 minutes a day, 3 times a week, 30 minutes is sufficient over a period of 6 to 12 months to induce PGC1 alpha in the skeletal muscle. And it doesn't need to be intense. It just could be a spinning class or a moving class. That's what we know. So the second would be sort of this fusion-fission process. Mitochondria are never in isolation. They're almost like a grid. They're a tight community. We have now developed a technology called transmission electron microscopy. We can actually see the grid at work inside any kind of cell. And they like to talk to each other. And they fuse with each other. They kind of communicate with each other. So that's another process that declines. And so you can just simply, and that's where NAD modulators, creatine works, because it just is acting as a fuel for these healthy mitochondria to keep talking to each other. Mitophagy is the third part of that life cycle. It's just damaged mitochondria, stressed mitochondria that put out an eat me signal. And with aging, they just clog the real estate inside a cell. So you can't really have PGC1 alpha. You can't really have biogenesis happening. And so when we have for long studied mitophagy and how to activate it, we know that this molecule that we talk about, urolithin A, can activate mitophagy. So it will upregulate things like Parkin proteins, which are signals for the mitophagy to start. A few weeks later, we'll suddenly start seeing PGC1 alpha go up. So it's not instantly we'll see PGC1 alpha go up. You have to start the machinery to recycle. The building blocks come from that recycling. That's the whole life cycle.
Thank you to Timeline for sponsoring today's episode. As we step into the new year, we're all thinking about routines, what to start, what to stop, and what to finally commit to. But the body doesn't respond to resolutions, it responds to consistency. And lasting health isn't built on trends, it's built on fundamentals. Quality nutrition, resistance training, recovery, and cellular energy. Every second, your cells are producing energy. That energy determines how strong you will feel, how well you perform, and how resilient you are over time. And unfortunately, as we age, that system breaks down. The mitochondria, which we know are the engines inside your cells, wear out faster than the body can replace them. And that's where Timeline, powered by Mitopure, comes in. Mitopure supports mitochondrial renewal, and it's been shown to increase muscle strength by roughly 12%, even without changes in exercise, by improving cellular energy where it matters most. Muscle is the organ of longevity, and without strong mitochondria, you can't have strong muscles. If staying forever strong is part of your plan, get 35% off Mitopure subscription at timeline.com/Dr. Lyon. Let's say someone isn't able to push this PARK pathway. And there's various pathways. In geriatrics, when we think about aging, if let's say someone's glutathione production goes down, and this is for the listener or the viewer, this is the master antioxidant. We know that there are other pathways or other gene regulating systems that will upregulate to be able to account for this inability to, say, make sufficient glutathione or something like this.
Sure.
And so it makes me think, if urolithin A is an inducer in mitophagy to help clean out these old mitochondria and help with immune remodeling, but someone isn't able to push that pathway forward, is there an alternative pathway that one could push?
Possibly, yes. And I think there is research, still very naive, coming. Well, is there, and probably I'm geeking out now, so there is a PARK-dependent mitophagy pathway, and there's a Parkin, independent pathway. All roads will lead to having near healthy mitochondria.
I would absolutely agree with you. And one of my colleagues, she's a PhD from Princeton, Dr. Alexis Cowan, her and I fight about, I think it's all about muscle and she thinks it's about mitochondria. I don't want to tell her that I recognize that there's a ton of mitochondria in muscle and that this is really what's making it healthy. But these outcomes that you chose, and this was after 28 days?
4 weeks of supplementation.
Okay, 4 weeks. So 28 days. Do you anticipate, if we are thinking about healthy mitochondria, healthy immune system, healthy muscle, 1,000 milligrams of urolithin A after 28 days shows improvement? What do you consider, say, after 4 months? So again, these are short-term trials, which maybe is some of the criticism of urolithin A. Again, it's been around. You guys have been studying it for 10 years. It's not new. Yet in science world, anything less than 20 years is new.
Yes, I 200% agree. So research is always a continuum, right? You start somewhere, you discover something, and you have to keep building on it. Over 10 is, as you said, too young. So probably I need to keep doing this another 10 years to figure out. And that's how biology is. There's no magic bullet. So yes, 4 weeks is short. But what we were really trying to see is there a cellular signal and is there a physiological signal on the immune system? Even when we did trials on skeletal muscle, in 1 month, it's just the remodeling happening at a cellular level. The effects come much later, around 2 and 4 months, when we start seeing impacts on leg strength, better peak VO2. I believe that, and it's on me actually. Now we do need to do the longer trials. We need to do these 6 month to a year trials.
It's hard for compliance.
And it's hard for compliance. Older people, also you will have bigger problems in compliance. But that's where we are headed. We were just recognized, for example, with the X Prize, one of the short list winners of the X Prize. And the goal is to do a 1-year study called the Health Span Study, where we are looking at these 3 key organs: the muscle function over a year in healthy adults, 50, 60-year-olds, immune health, not any complicated as I did in this particular study.
But you mean you're not talking about sporadic inclusion body myositis?
Yeah, that will make it a drug trial, unfortunately.
Okay.
And the third is cognition, because that's the key factor is, the cognitive health will decline in these and so that's what we are doing is these long-term trials. But I do think the signal as an immunologist that there is a rewiring happening is proof. And now I'm doing trials on cancer patients, for example, or post-cancer patients who have beaten cancer, but their immune system, the healthy immune system, is also gone. So these are the future trials we're doing.
I think that it's going to be fascinating to see what these outcomes are.
Sure.
The other aspect of it is, if you look at it for 28 days, you're thinking about these molecular changes.
Yes.
That may, and actually they're phenotypic changes, so they're molecular, but you're seeing them in the cells.
Yeah.
What about other health outcomes, primary endpoints like HSCRP or increase in lymphocyte activity?
Yeah. So we did that as secondary endpoints in this trial, and HSCRP is probably, and that's how we got interested actually in all the previous trials, the longer trials of 4 months, whether it was the older adults, whether it was the 50-year-olds, and now more recently, we've even done trials in Olympian runners and athletes who performance doesn't dramatically go big, but we see blunting of the inflammation. So that's how we got into that we were seeing these significant effects on HSCRP, or what's happening at the immune system. So I do believe that we are seeing this first snapshot of how the immune system is remodeling. And now we need to do longer trials and see if, over a flu season, if people got less sick, or easier would be to give them a flu shot and track the antibody levels and the specific immune cells that are specific for flu, which we can trace them.
You had just started doing this research, so I hope I'm not throwing you a curveball and you don't want to talk about it, but joint health and cartilage health.
Yes.
Tell me a little bit about what you're looking at and what you're seeing that, because when I think about aging and activity, the things that take people out are the following. Number one, they feel like they don't have enough energy to train, which then we know gets worse. And then also joint pain. And I know that your group was looking at various compounds and things for joint remodeling. Maybe these were chondrocytes. Were you guys looking at that?
Yes, so we were actually doing a collaboration with Professor Martin Lodz in the Scripps Research Institute, and he studied cartilage and conditions of the joint like osteoarthritis for almost entire career. He sent us damaged joints from osteoarthritic 50, 60-year-old patients, and he was getting a hint that the mitochondria were involved. We actually focused first on if autophagy was shot in the joints, and the signal was shockingly amazing that autophagy in general was so much lower in these damaged joints. And so he then did the study where he took these osteoarthritic models and supplemented them with urolithin A, and he saw higher autophagy in the joints, less degeneration, but third, most importantly, lower inflammation in the joints. So that's how I think the signal we see in multiple organs and multiple studies is this trifecta. We see better, more autophagy, mitophagy, we see lower inflammation, and then we start seeing the organ-specific effects.
Do these compounds cross the blood-brain barrier?
That's the research we are doing right now. So you hit it on the.
So I have to wait another year to hear about this? Okay.
Actually, there's a paper that just came out showing that amongst all the urolithins, because the body does make a few different kind of urolithin.
What other kind of compounds?
So when you take drink a glass of juice, or you take a bowl of raspberries or nuts, your body, the gut microbiome will digest these complex polyphenols and release this postbiotic compound, urolithin A. But in smaller amounts in some other individuals, there is, instead of urolithin A, you can get urolithin B, for example. It's just a different gut microbiome that shifts it to a different pathway. And there's also some percentage with urolithin C and urolithin D. These are the four.
You guys better get going. You have a whole alphabet to work on.
Amongst all the urolithins, the urolithin A is the one that actually is made the most. About 60% people of the ones who make it have urolithin A, and it's the one that crosses the blood-brain barrier.
Thank you to Manacora for sponsoring today's episode. Winter means more time indoors, more travel, and if you have kids, a new bug, cough, or sneeze every other day. I like keeping my routine simple, and Manacora has become something I reach for almost every morning. And why do I love it? It is rich and creamy. It tastes delicious. I either take it right from the spoon or I use these little packs. It coats my throat, tastes amazing. Now, what makes Manacora special is where it comes from. Their beekeepers work in this remote forest of New Zealand where the bees collect nectar from the Manuka tea tree. Yeah, so cool. And this plant is naturally rich in bioactive ingredients. So basically, the honey that you have ends up with 3 times more antioxidants and prebiotics than regular honey. And because it contains MGO, which is a rare antibacterial compound, Manuka honey has benefits that you don't get from other honeys. And all you need is 1 teaspoon to get the most out of these amazing bioactive ingredients in Manuka honey. And now it's easier than ever to try Manacora honey. Head to manacora.com/Dr. Lyon to save up to 31% plus $25 worth of this free starter kit, which is amazing. I have one. It comes with this massive jar of Manuka honey. That is, go to manacora.com/Dr. Lyon and save 31% plus $25 worth of free gifts. I know that you primarily study urolithin A, but have you seen other kind of compounds that were of interest that perhaps push? And is it fair to say, are we talking about autophagy or mitophagy? If we focus on mitophagy, is that one group of compounds perhaps outside of urolithin A?
Mitophagy is very targeted, so I think there are very few things that are known to do that. Exercise is by far the biggest inducer of mitophagy. Caloric restriction, so eating 15-20% less, also is known mitophagy inducer. Urolithin A is probably one of the few safe and clinically studied compounds that have shown to induce mitophagy. I do believe that things that induce mitophagy will induce autophagy at a cellular level. There are a lot of autophagy inducers that perhaps have not been studied for their mitophagy targeted effects.
I see. So autophagy is the broad umbrella,
yeah,
and mitophagy is singularly focused on the mitochondria.
Yeah. So if you're looking to boost your mitochondrial health in a very targeted way, that's where urolithin A comes in. But if you're looking at autophagy and, for example, mitochondrial health overall, maybe there are things that you can add on. Like, for example, there's this compound called spermidine that is known to be an autophagy inducer.
How do we make that? Is that a postbiotic as well?
No, it's found in the diet. It's in small trace amounts in certain fermented foods, like, for example, in cheese and things like this. And it's also found in certain fluids like semen, and that's how it's, the sperm
It's
or
not on the
sperms.
diet. I'm just
That's
kidding.
the name coming
Matt,
from.
my producer over there is perked up. Spermidine, that would make sense. What do we know if there are others?
Yeah, there are definitely there are drugs that are known to induce autophagy and have targeted. We can talk about mitochondria. When you talk about mitochondria, metformin is probably
I pulled that one.
a very common inducer of autophagy, and this energy pathway called AMPK. Have people thought about adding this plus other? I think that's where the field is headed. Really is. I personally believe that if you can get autophagy and mitophagy revved up as the foundation of your cellular health, anything that you're layering, like whether you're into creatine or you're into NAD boosters, they will work better. Just because now you have the real estate to do whatever you want to do inside in terms of cellular health.
The dietary component, do you think that this is a way for us to inform how we should be eating if we were to focus on these compounds as opposed to the macronutrients?
You mean like a precision nutrition
Yeah,
approach?
it's a hefty question.
Yeah.
Meaning, so typically I believe that we should protect muscle at all costs.
Yes.
Which means various amino acids. Secondarily, however, I agree with you in the idea that it's not just this macronutrient, protein, fat, and carbohydrates, but it's also these bioactive ingredients.
Yeah.
Again, so we prioritize high quality proteins, but then we would be informed about foods that would then produce urolithin A or spermidine or urolithin B, C, and D.
Yeah. I think the science is coming up in that direction. That's where the field is headed. Can we combine, what would the ideal, for example, we can talk about it, what would be the muscle longevity supplement have? It will have proteins and amino acids. It will probably have creatine. And I do believe the third missing element would be the sort of a mitochondrial rejuvenator in that mix. So if you take protein, you'll get muscle protein synthesis. Where will that happen? It will happen at the mitochondrial level, right? So if your mitochondria are in top shape, you'll just absorb and you'll have a better effect of these proteins, or even creatine, I believe.
Have you looked at additional compounds, say vitamin C for immune health? Coming into the season of colds and flus, people say, okay, well, take vitamin C, take ascorbic acid, or take zinc for immune health.
So we club them all together, zinc, vitamin D's, C's. If I have to take something for my immune system, I would take vitamin D, just because there's so much evidence on immune cells have a vitamin D receptor. And so there is the biology behind it. Vitamin C, I'm not really sure I can explain it to you how it works. Just that, over the last 20, 30 years, there's this sort of anecdotal belief that vitamin C works as an antioxidant to give you sort of this temporary boost and that temporary boost is really what I believe is like, if the immune system is your surveillance sort of setup, the vitamin C is only hitting the neighborhood watchdog, right? The people.
So it's not super helpful. It's basically.
Vitamin D and urolithin A and mitochondrial targeted compounds, I believe, are getting your police and the elite forces of the immune system strengthened up. So you have not just lifelong, the whole year you have a good immune system. And that's kind of where the field is going.
One of the things that we were talking about before, actually you weren't in there. Oh, actually I did mention it to you briefly, is that people will say, okay, well, I'm not feeling well. Maybe I shouldn't work out. Is there a role for exercise and immunity? And at what point do we say, okay, your CD8 cells are off the charts, or your leukocytes or white blood cells are off the chart? Maybe you should chill on training. Do we have, and that's more of a clinical question.
So most people who study how exercise affects muscle, mitochondrial health, they focus there. And that's one of the problems in research.
What do you mean they focus on? Tell me.
So there are a few groups that have actually found that exercise does everything that we have just published with urolithin A. They found that just a 30-minute strength training for a week has an effect on your naive CD8 T-cells. It has an effect on blunting these pro-inflammatory markers like interleukin-6 or HSCRP. It has an effect on boosting biogenesis in the mitochondria in your immune cells. So there are a few studies. It's just not as deeply studied as the effect of exercise on, let's say, muscle protein synthesis.
Would it be, for example, let's say if we were to compare training and urolithin A. Urolithin A, you study 28 days, 4 weeks.
Yeah.
Minimum, we see an improvement in the phenotype and the quality of the immune response and immune cells. Conversely, if you were to do a bout of resistance training, let's just pick resistance training, do we think, or is there data that it would also have a change in a phenotypic expression in the short term? So it takes 28 days, which would make sense, right? A nutrition influence isn't, I mean, I guess maybe it could be an immediate, but where is it, to wrap up the question, is it acute or chronic activity that would then affect immune cell function from exercise?
I think it will still be chronic activity, probably will be accelerated. You perhaps don't need 28 days. Maybe it happens in less, 2-3 weeks. What we haven't gone there yet, and perhaps that's what we need to do, is combine exercise or fasting with supplementation with something like urolithin A. But we have started looking at the additive effects on muscle, and can that be accelerated, for example? And this is mostly research I'm not doing. I'm collaborating with the top labs that work on weightlifters who do a lot of resistance training, or elite runners who do a lot of training to get their peak VO2 up, their aerobic endurance up. And what we are finding is there is an additive effect of the two, exercise.
It would make sense.
Yeah.
And what you're saying is that there is an additive effect of the compound plus the actual training. And when you say additive effect, these are performance outcomes, not phenotypic expressions?
Not pheno, and that's where probably is the next step. So we need to go, all our research has been so heavily invested and focused on muscle and mitochondria that we just...
For good reason, friend.
Yes. So we're just starting the first baby steps on looking at the immune function and the phenotype.
The baby steps. Was there, I mean, that is kind of counterintuitive considering you're an immunologist. Were you most surprised at the influence of immune cells on muscle, or was it something that you had already been thinking about?
So I had been thinking about, but I'm an evidence-based person, and of course I need to
We don't like those here.
We need to do the trials to see the effect, and I personally feel two fields have been understudied: this immune metabolic axis, so the role of mitochondria and energy metabolism on immune cells, and how that changes as we get older.
I want to pause right there.
Yeah.
Can you expand on that? Where you think the connection is? Let's say, for example, we have immune cell dysregulation. And we know that we want immune cells to utilize free fatty acids. And I understand that it's probably not a major energy driver like mitochondria, right?
Yeah.
However, on the same vein, if we have immune cells that are being forced to use glucose, from just a clinical standpoint, do you imagine that there would be an outcome similar to, say, diabetes or elevated blood sugar? How, as a practicing physician, you know, I still see patients.
Yes.
By the way, you do know that. Okay, good. Ian has done his job. But how do you see that present clinically?
So I'll give you an example of the field that is turning around, and that's the field of neurodegeneration. For many years, things like Alzheimer's were basically protein deposits in the brain.
Tau deposits?
Beta-amyloid tau, inclusion bodies. That's what they are. Now it turns out that all the immune cells, the microglial cells and all the immune cells that they can actually cross, they are in the super dysregulated state. They are in a super inflamed state. And now that whole field is turning out that actually Alzheimer's is an inflammatory disease.
Of the brain.
Of the brain.
As opposed to the traditional thinking. From my understanding, Alzheimer's disease, there's various types of dementias.
Yes.
There's vascular dementia, there's frontal temporal dementia. There's Alzheimer's disease, which is often thought of as a type 3 diabetes of the brain, a metabolic disease of the brain, an insulin-resistant state of the brain.
Yeah.
Subsequently, we would see beta amyloid or tau proteins, right? So this is the kind of the landscape.
Perfect. Yeah. And that has shifted now to, well, maybe it's just not that. Maybe there is another component, and that is the immune dysregulation part. So it's really the combo of the two.
You know, if it's the immune dysregulation part, the only lever that I am hearing to pull for optimizing immune health would be diet. And correct me, like, how do we optimize for our immune health?
I certainly think it's the first event. It's like, the first brick falls and then the other bricks keep falling, that kind of a situation. I think immune system dysregulation is the first brick that falls that accelerates this aging cascade.
And do you think it's like exposure to COVID or the flu because we want a certain level of stress?
Yes.
Is it environmental? I was reading about the effects of environmental exposures, air quality exposures, VOCs, on cardiovascular and atherogenic outcomes.
It's a mix of a lot of factors, I believe. Everything you said, plus the watchmen that keep all the immune system in check. So I don't know if you followed the Nobel Prize in medicine this year.
I'm too busy watching Baby Shark.
It was for immune system this year. And for the discovery that there are these, out of 10 T cells, there's these 10% immune cells that keep the other guys in check. They go, the police itself goes bad.
Is that CD8?
Those are called T regulatory cells, and they go bad, and then the whole cascade starts.
But how does that happen?
How does that happen? It's the field of immune regulation where we are still not clear how that happens.
How do you think it happens?
I believe the immune system just loses firepower.
Is that from exercise, physical activity, obesity?
Absolutely. All these, the same factors always show up. Lack of physical activity.
Do you think that's the primary?
I believe diet and exercise, a lack of physical exercise and eating more carbs or the wrong fats, that's probably, and to a certain extent, what you said, the stressors in the environment.
I think it's physical inactivity.
I have spent a long time looking at frail older people and how their immune system, it's like it's dead.
It's so it's tough, right?
Yeah.
But imagine, so senescent cells are not dead cells. Those, right? They are in a state of limbo.
Yeah.
Right?
Yeah.
If there was a way to apply pressure and stress physically, because listen, as we're talking about all this really deep science stuff, which by the way, so much fun for me. This is better than shopping online. That we can talk about metformin, we can talk about AMPK, but if we think about the majority of the population and the people that are listening to this are very interested into health and wellness.
Yeah.
And if they are not, I'm hoping that we can convince them, is that there's a lot of distraction out there and there's a lot of information. We do know that diet and exercise, it plays a huge role in the health of immune system and mitochondria, right?
Yes.
We can agree on that.
Correct.
But what you're saying is that even before we think about diet and exercise, right, because this has to happen, there are probably subtle things that are happening that are leading up to T-cell dysregulation. And if I'm a betting woman, and you and I might see eye to eye, maybe we see different, from my perspective, it has to be the stasis of muscle.
I tend to agree.
Because even if you are exercising muscle and you're creating low-grade inflammation, which you want, then you're eliciting activity from the immune cells to then deal with this inflammation. Is that kind of how we imagine it happens?
Absolutely. I think you started touching on it. Well, when people are feeling a little down with a little sore throat and, a little fatigue, is it a good idea to go and try to work out a little bit? I think it's actually a very good idea. I think exercise is that stimulus and we see it for the muscle, we see it for the brain. Immune system is no longer different,
I think that's a great, and you said 3 days a week of 30 minutes just to start build immunity.
Yeah.
And if someone was sick, do you think it matters if they do resistance training, walking, cardiovascular activity? Do you think that there is a heart rate level that has to come up? Is it blood flow? Is it just stressing the system?
I think it's just a matter of getting your muscles activated and moving. Now, how
agree
that
with you.
happens, before the show, we started talking. The longest living people are being studied now, and it is shocking to me. And they are physically active all their life. They ate fresh food from the farm. And guess what? Their immune system looks great. Their muscles look great. And their brain is very alert. So I think physical activity and diet is probably the key for all. And low stress, maybe.
No, I think a reinterpretation of stress.
A reinterpretation of stress, yes. A certain tolerable level. Stress is fine. Yeah.
Yeah, I mean, we typically think about stress as fight or flight,
Yeah.
but there are other stress responses that are not really discussed.
Yes.
Tend and befriend and the courage response. But if
Yeah.
we always are thinking about fight or flight, then we tend to seem to elicit that response. Now, placebo affects 30%, right? You would see a 30% improvement with a placebo. Is that still the case? So, for example, if I say, hey, Anurag, take this pill, you're going to get better. Maybe there's a 30% chance that works.
That will work for muscle, and I see that in my trials, because if I tell an 80-year-old person, you're participating in a trial, and I don't tell them what they're going to be. I'm going to randomize you to a placebo or a supplement or an intervention that is going to make your muscles more healthy. For the next 4 months, guess what they're going to do? They're going to move more. They're going to garden more, and that itself will give them that 20-30%. Immune system, you cannot deceive. That's the
Wow.
immune system you cannot deceive. You've lost your naive CD8 T-cells. No placebo in the world, even if they move a little bit, will have that meaningful change. Muscle, it will.
Did you find that interesting?
Yeah, of course. Yeah, which is why now as I think about, the holy grail in the mitochondrial field is there a mitochondrial marker I can use in my clinic, right? A lot of scientists do a lot of stuff to look at mitochondrial health. Can I do it? And for many years, I did many skeletal muscle biopsies. And when I tell an older person or a 50-year-old, well, come to my trial, you're going to get probably better, 50% chance. But I need a little piece of your muscle.
Worst.
They say, oh, forget it. Most of them say. But if I tell them I'm going to take a little bit of your, few drops of your blood, and I'm going to tell you, because these immune cells are going everywhere, and I can study their mitochondria. Very easy. Every doctor in the world takes a few ml of blood.
Or if you come to my clinic, you take a lot more.
Yeah. So it's very easy to get an idea of how good your overall mitochondrial health is by just looking at the mitochondrial health of your immune cell.
Okay. Are we looking at white blood cells? Are we looking at leukocytes? Are we looking at, monocytes? Or are we looking at something different?
No, I think we have to do it with the tools we have today. The technology and tools I was describing probably in mainstream medicine will take 5-10 years
So you're
more.
holding out on us, aren't you?
Well, it's too expensive. So, every doctor, I don't see purifying the T cells out of all your whole.
Could you though? Could you?
Yes, I did that 20 years back.
I gotta tell you, muscle biopsies and fat biopsies were my least favorite part about doing research.
Yeah. So,
are you still the one who has to do it? Do you have a grad student or something?
no,
You have to do it?
Well, I can find an orthopedic surgeon to do it who does it in their
Well,
sleep.
when we're done with this podcast, I will tell you stories, or I would go in there 4 a.m. just sweating like, oh my God.
But I can take a few amounts of blood from anybody, and that's easy for me to study. In total leukocyte count,
Total leukocyte count.
I would look at lymphocyte percentage in there.
Where do you think that should be?
I think you have about 20 to 30% of all your total leukocytes would be lymphocytes, and they decline probably like muscle declines, 10% every 10 years or something, and then accelerates. It's a similar decline for these lymphocytes. I think even a 1% or 2% increase in total lymphocytes is clinically meaningful like crazy.
In what way? So basically, a normal absolute lymphocyte count, which would be ALC, which no one ever calls it that, is 1,000 to 480,000 cells
Per million.
Yeah.
Yeah. ML of blood. Yeah.
That's right. You want that to be higher, or you want it to be lower?
You want to be in that range, and with aging, this goes below that threshold. And so you want it to be where you were when you were in your 30s and 40s and 50s, kind of the levels when you hit
Kids
70.
go up to 9,500.
Yeah.
3,000 to 9,500.
Yeah. because they have more stressors, right? I mean, if you think about, well, my daughter, when she was in daycare, she
My
was
kids
always
eat
sick.
off the floor, so I
Yeah.
don't know. Yes. What about, so you don't want it too low. That's
That's lymphopenia.
lymphocytopenia.
Yeah.
And then you don't want it too high because that's lymphocytosis.
Yes.
And that would that be a risk factor for then cancers as well? So now this is a dysregulation.
Or autoimmune diseases.
Okay.
Yeah.
Can you touch on that, or is that outside of the question scope here? But
Yeah, so what we see in our trial is sort of immune modulation rather than, blasting immune proliferation, which will continue without any plateau or threshold. So I do believe sort of this 5 to 10% changes we are seeing in immune remodeling.
Wow.
And arming this army better with better, healthier mitochondria. That's kind of where and then what we did actually in this trial, which some were hidden in the...
Is this the trial? This is the new Nature and Aging trial?
we took the immune cells out and we actually put a stressor like a bacterial infection. The immune cells were able to kill the infection much faster, about 20% better than the placebo-controlled immune.
Wait, time out. This is great for the winter. Is this in this recent trial that you did?
Yes.
This is the one in Nature and Aging, the effect of mitophagy on inducer urolithin A on age-related immune decline.
So all the nerdy stuff we talk about in the end has to...
Speak for yourself, yeah.
to come to a functional benefit. Is your immune system better at fighting infection? That's what we were testing. But now we need to do what is called field trials, where, as I was saying, we need to give a flu vaccination to old people and see if their immune system responded and they had less, from September to February, did they have less episodes? So that's the kind of trials we need to do.
Where do you think the future is going in terms of testing for, again, we talked about the lymphocyte count, but that's immune system. That's not necessarily mitochondrial health.
Yeah.
Are there markers of mitochondrial health that maybe are not just commonplace, but you guys are using in research, which means eventually it will come to the general population?
Yeah, so we are working with the Buck Institute of Aging that has these really advanced sort of equipments that can look at a single cell level, single immune cell level. Are they using fats more? Are they using glucose? I think that's at least 10 years away. But what we can also do is we've partnered in this trial, and that's probably going to be the next publication. Is we partnered with a company called True Diagnostic to look at to look at the if you're having better cellular health, at some point you probably have induced epigenetic alterations, and that will show up in the biological age of these immune cells.
Which mean, so is that algorithmic where they'll say your HSCRP is X, your, lymphocyte to monocyte ratio is this, is that? So there's not one marker where I go, okay, Matt Santiago, come over here, I'm going to test your blood, and your mitochondrial alpha PGC1A is 500.
Yes. So that's where I think the field probably will go next. In addition, what the field will do in 10 years time frame is how's the mitochondrial function of your immune cells.
Do you think there are compounds that can improve that?
Well, that's what I guess we have published in this trial, but exercise would definitely do it.
Well, I'm just teeing you up here for this.
And so rapamycin, for example, talked about a lot in the longevity field. They're pro and anti people against using rapamycin. It's developed as an immune suppressive drug. It's prescribed by doctors after transplantation. So that's one drug I wouldn't think in the longevity field that is rejuvenating the immune system.
Talk to me about rapamycin. I don't prescribe rapamycin.
Yeah.
I think that there's a lot of talk about it, but I need to see randomized controlled trials before I feel good about it because it inhibits mTOR.
Yeah.
And so rapamycin is this antifungal agent that was developed on Easter Island. Is it Esther Island?
Easter Island.
Easter Island,
yeah.
with those big heads, which are super cool.
Yeah.
And basically, it inhibits mTOR. And mTOR is not great in all the stuff. There's mTOR in this complex in brain and
Muscle,
liver
yeah.
and muscle. We want it to work in muscle, but it's supposed to inhibit this and somehow cause people to live longer. Is that your understanding?
That's exactly the idea.
It is used off-label, which, again, I'm trying to be open-minded. What are you seeing it being used for, and how would someone say, okay, we're going to use rapamycin off-label for, I don't know, mTOR inhibition? Oh, and by the way, wouldn't that affect skeletal muscle mass?
Absolutely. And I personally feel the one drug, if there is sort of this repurposing drugs idea where, you have an approved drug that is known to be safe for, for metformin, for example, it's for diabetes, for rapamycin, it's for immunosuppression. I think the only candidate right now we have is metformin, to be honest.
What about GLP-1s?
GLP-1, of course. So these are the new kids on the block.
Wait, and by new, you have to be fair and say, what, 20 years old?
Yeah, they have been known for diabetes. I know actually the two professors who discovered that these were acting on sort of the whole insulin pathway, and it could be used as diabetic drugs. And they have been used as
exactly for years,
for many years. And
yeah.
More recently, they kind of figured out as a side effect that obese diabetics were losing weight on it, and that's how it started. I do think there is more research needed on these GLP-1 drugs, but yes, they could be potential longevity drugs like metformin.
So you like metformin. If you were to say, what is another drug that we could repurpose?
I would say metformin, and there are folks like Nir Balzai studying that in a big TAME trial, 2-year effects of metformin. So we need to wait to see the data, but it's a good candidate.
And also the combination of metformin and urolithin A. This was a really well done study. Again, it has gotten a lot of press. This Nature and Aging is really, I think it's kind of exploded, essentially. When you were looking at this, and again, there's a lot of trials about urolithin A, aging, effects on muscle strength, inflammation, but with this immune response, I think is extremely relevant. What do you think the optimal dose is? So we have 500 to 1,000. Most of the data out there that I'm seeing emerging is 1,000 milligrams of urolithin A. Let's say someone has cancer. And I know you can't say that, but let's just pretend. Do you think it would be 2,000? Is there a saturation point?
So I have done those studies long back. At 2 gram, if you take 2 gram in one go.
I do, by the way.
You kind of get the same levels of urolithin A that you would get at a gram. Okay? So what does that mean?
So my 8 gummies that I'm eating I shouldn't be eating 8?
I think you need to split it. So you need to take a gram in the morning and maybe a gram later in the afternoon. So you're always having this, peak levels throughout the day versus kind of going. So from the time you eat these gummies or pills or whatever, urolithin A will peak in the blood around 6 to 8 hours. And then there's a gradual decline. So the idea is you want to keep those levels up longer. A gram is where if I see somebody who's struggling with inflammation, or potentially, as you mentioned, somebody who has cancer, that's where I would start them. If somebody is very healthy, doing exercise, doing all the other stuff, and we haven't done that trial yet, but I would assume 500 milligram, just because we said exercise would probably be doing all these things.
And the reality is, I actually really admire you for saying and being very clear about the evidence in terms of the information that you're saying, listen, we know exercise works.
Yeah.
And I really appreciate that. And I will also say that the majority of people are not exercising.
True.
And so
especially older.
Absolutely. And we do have to account for how do we create an even playing field for immune health, for mitochondrial health. In the trial, the other thing that I noticed, which perhaps would be considered a criticism, is that the individuals that were the 50 healthy adults, 45 to 70, but they didn't have, if we know a huge percentage of the population is obese or diabetic or have that, do you think this compound would be as effective in someone who wasn't considered, quote, healthy?
Absolutely healthy, you mean?
Who's not
healthy. We haven't looked at the immune system in terms of somebody who's overweight or obese or...
You have or have not?
Have not. have not. But we have looked at overweight and pre-frail folks for muscle health, and this compound behaves the same way, whether it's in healthy 40, 50-year-olds or obese 40, 50-year-olds. And perhaps, and as a trialist, you always have to ask when you're looking at designing a trial and what the primary endpoint is, what is the delta I'm going to see and how big is the gap in that person? I believe the effects would be even more dramatic in compromised population, because I probably expect...
In a positive way.
Yeah, in a positive way. Because
I think so too.
They're starting
actually.
much lower compared to somebody who's healthy. And so you can increase their whatever effects and see much faster or in a better magnitude.
Someone who's listening to this, who's a practitioner or provider or someone who is interested in their own health, I just want to circle back to things that they could measure. Mm-hmm. And one of the trials, I don't know if you were involved in this, but it showed that creatine kinase, which is typically an indicator of muscle damage,
Sure.
was lower. Mm-hmm. Those that were using the compound, again, urolithin A. I haven't dove so much into the study, so I don't know the quality of the trial. And this was, okay, so it was in sports medicine. Mm-hmm. Urolithin A enhances recovery and aerobic capacity in elite endurance runners. Because I know that you've worked with soccer players. It said that it was associated with a lower perceived exertion, which I use it and I experienced that. My dad's into it too. Reduced creatine kinase. Mm-hmm. I mean, that's an objective marker of muscle damage.
Yeah.
After harder efforts.
Yes.
And I bet you, side note, probably helps with rhabdo, which I've gotten. Not very proud of that.
Yeah, so this study, by the way, is done by the most revered and published sports researcher on planet Earth, and that's Professor Louise Burke. She's in Australia, and she trained many top athletes.
She's amazing.
Australia has ever produced. So she actually came many years back to me, and she said, "Well, these runners are overtraining, and their mitochondria are damaged, but what is essentially the problem is muscle damage and recovery." And so I want to test your compound. I wasn't sure, to be honest. I was like, well, I'm not sure if it's going to work. But yes, it didn't show performance benefits, but it did show endurance benefits in this trial. It's a beautifully designed trial she did. But I think, as you pointed out, the muscle damage and the ability of the body and the muscle to recover after stress was so much better.
And you feel like this was a well-designed trial. Again, this was
Louise
double-blind, parallel group, placebo-controlled trial. Yeah. It was competitive male distance runners.
True.
I mean,
so maybe that's the criticism as well.
I think it's super important to obviously study both men and women, but I think when it comes down to it, the performance, the muscular challenge is muscular challenge, regardless of the milieu of hormones.
We've made a conscious effort in all our randomized trials to have both men and women, and actually we have 60% women in every trial. Even the latest Nature Aging is 60% women. It's
really well done, and I'm excited to hear more about what is going to be on the forefront. What do you think is next? So I know that you said brain.
Yeah. So two topics that I'm very, let's say, excited about to research. One is to build on this immune rejuvenation story and take the next step forward. And the next step forward, obviously, is what's going on with cancer. Because what happens with aging is, as we get older, our immune system becomes poor at surveillance. It can't really keep all these sort of malignant cells that, in check, that start dividing, and that's how cancer happens. So what we're doing is we're taking a same approach, 50 patients with lung cancer. We're giving them the standard of care, which is the top-line immunotherapy, and then we're adding urolithin A on top to see if we can up the game of the standard of care. Because I believe nutrition and nutritional supplements have a chance. They only have a chance to add on in these very well-developed drugs. The second is brain health. I think that's really the final frontier for us. If we can, and so obviously the study is taking lumbar punctures and making sure urolithin A is crossing and for once and show in different populations, and then doing PET scans. So it's kind of trying to do what we call FDG PET, seeing how glucose is absorbed in the brain with and without urolithin A. So that's kind of where we're headed.
So it does cross the blood-brain barrier.
Yeah, in different models of animals in the brain. So now we need to make sure in humans We have concrete proof because in humans you can't biopsy the brain, so all you have is
Good luck getting that approved.
is to get the lumbar or spinal taps done.
Do you think that it's a different metabolite? So it's urolithin A is one metabolite.
Yeah.
Do you think that potentially there's another metabolite of urolithin A?
Yeah, so urolithin A, we know a lot of it gets conjugated in the liver. It goes through phase 2 metabolism and it gets either glucuronidated or sulfated. And the one metabolite we believe crosses is the sulfate with the parent molecule, which is the urolithin A. So we're going to look at all.
Do you think that there's a way to take it that's already, so if you were to target brain health,
Yeah.
would there be another molecule, a urolithin A plus, a brain component?
So brain, I believe, is much like I think about muscle. I don't think there's a magic bullet other than exercise and
Just don't say sleep. But
yeah. So I do believe you need a kind of multi-prong approach, right? So if we talked about muscle, it has to be creatine plus protein or creatine and urolithin A. For the brain, I think similarly.
Creatine too. You mean what's good for muscles, good for brain?
Probably that's true, but what happens with brain aging is your lipids that coat your neurons, they become weaker. So you need to maybe think about a phospholipid or a compound that can penetrate the brain and kind of repair the myelin sheath or this lipid layer. So there are a lot of compounds that have been studied. Phosphatidylserine is a typical example. Then you need to see which minerals and vitamins go down in the brain with aging. All the vitamin Bs go down, the main ones. Selenium. This is something that I've become very interested. Selenium is sort of this neural repair, neuroplastic mineral that with aging just disappears. Just, our brains go deprived of selenium.
And it's not from the soil, it's not from the environment?
It could be. There could be a component of that, but I do think if you look at an older adult study where they've looked at how much selenium is getting in their brain versus a 40-year-old or a 20-year-old, they'll find about 3-fold, 4-fold lower selenium.
Wow.
And if you supplement in models of neurodegeneration, you'll kind of repair all the neural degeneration.
Interesting. So it does cross the blood-brain barrier from a dietary perspective.
And then we are looking at what other antioxidants we can look. And one where we see some, at the cellular level of synergy, is a compound called ergothioneine, which is basically found in a lot of these medicinal mushrooms and is also hitting the same biology at mitochondria that we see with the compounds like NAD boosters, for example.
Did you say ergothioneine?
Theanine. Yeah, it's an upcoming molecule, but we started working on it. And so that's sort of the area where we have, out of about 40, 50 different supplements and other top candidates, we've done like a funnel approach in the lab, and we've come to this magic brew of 3 or 4 compounds that we are hoping to test in a big trial of 600 people.
That's great.
Well, that's what we need to do, right? In the supplement field, people always do these 40, 50 people trial. And so I said, for once, let's do a 600-person trial. And if it's going to work in the brain, you need a bigger cohort. It's not like immune cells where you take blood and then can map out the entire immune system.
That's going to be extremely cool. And that will you do it for a longer period of time, 6 months?
So first is what happens in a more subchronic situation. So you're doing an 8-week trial first to see what's happening. Are people, cognitively feeling? So we are selecting people who have sort of brain fog, or what I call subjective symptoms of cognitive decline. And then we're going to give them this product and see if there is an effect on cognitive health in about a 2-month span. But really the holy grail is the long-term effects in an older population for after 6 months, for example, or a year.
I love it. And I think that that's extremely meaningful.
Thank you.
Well, as always, Anurag, it's really just a pleasure. I get very into the conversation. I think that you bring such a great perspective and you're such a good scientist. Thank you so much for coming on the show.
Well, pleasure as always. Thank you for having me, Dr. Lyon, and for the conversation. Loved it.